Okay, so polar dissolves polar, nonpolar dissolves nonpolar. So oil and water, they don't mix because oil is nonpolar and water is polar. So they're opposite forces. And that's what I really want you to understand, is that when something dissolves in water, it's because they have similar forces. Not really bonding, but forces, similar forces. We're going to learn about forces next week. So here, the Na is attracted to the oxygen. So that's the big part of the head, right? The Mickey Mouse of water looks like this. So there's H2O. The water has big oxygen and then smaller hydrogens. All the oxygens are going to orient themselves around Na. All the hydrogens are going to be faced away from Na. And that's because we learned yesterday that water, I'll draw the different one here, that the water here has a dipole going towards oxygen, which makes it partially negative. And both of the hydrogens are partially positive. Again, that's because of everything we've already learned. It's polar, it's asymmetrical, there's a large difference of electronegativity. The electrons are being pulled towards the oxygen. So as a result, the oxygens are slightly or partially negative. Well, they're attracted to positive ions. That's why salt dissolves. And then over here with the Cl, it's the opposite. All right, I'm going to draw the hydrogens facing the Cl, and that's because the hydrogens are partially positive. So they are attracted to negative ions. Opposites attract. So whenever anything dissolves in water, this is kind of, basically this is what happens. All right, it just depends. You can substitute in different ions, different molecules. Sugar, for example. Okay, I feel like I'm talking really fast, so I hope you're staying with me. So sugar, if you dissolve sugar in water, it doesn't do this. Sugar doesn't have ions. It doesn't conduct. You prove that in lab. Sugar is covalent. But because sugar is polar, like water is, sugar also has these partial charges. So that's what water is attracted to, and that's why it dissolves sugar. So what I'm trying to get you to understand is this like dissolves like stuff. That's just a very general way to say it. If there's similar forces, like partial charges or ions, it will dissolve. That's all you need to know for the regions. That's all you need to know is if they have similar forces, they will dissolve. And that's why like dissolves like is the phrase. All right? So we will talk more about it the next unit in solution. So we'll talk more then. So I'm going to move on here. So plus we addressed it in lab. All right, so hopefully that makes some sense to you guys, and that's it for like dissolves like. Now, in that video, if you remember, when the water attracted to the Na+, I think it was like a red flash, and then when the Na and Cl were ripped apart, it was a blue flash. So what that's trying to teach you is this: bond energy. This is actually a pretty simple concept. I'm not going to spend much time on it. This is all I have time for. But the deal is, when bonds form, energy is released. And when bonds break, energy is absorbed. When Adam broke that pencil, he had to put energy into the pencil. You can't break anything without putting energy into it. Okay, if I took a sledgehammer and smashed the top of my desk, it would crack, it would break, because energy is transferring from me to the sledgehammer to the table. Okay? You all probably have heard of kids punching walls or whatever, breaking their hand. The reason they break their hand is they are transferring energy into the wall, but the wall is stronger than them. So therefore, their hand breaks. Okay, there's an energy transfer there. So you can't break a bone without transferring energy. Okay, energy has to go into the bone and say snap, and there goes your finger because you didn't think about what you were doing. So now, the concept there is I really focus on this one. If kids can remember, breaking something, energy must be put in, then the opposite is true. When you form a bond, when you put things back together, energy is released. That's harder to give you a real example of that. All right, but real quick, before the bell rings, give me a word for energy released. Exothermic, good. That's exothermic. Exothermic. And then what about absorbing energy? Endothermic, good, okay? So I wanted to give you a quick example. You know what, real quick, let's just put one down here. If we take Cl2 and break it into Cl and Cl, the only way that we can do that is if the energy is in the beginning. that's endo. Remember, energy on the left is endo. You're putting it in to break that Cl apart. And if it's the opposite, if we take two Cl's and put them together, then energy is given off. It's over on the product side. So here we're forming a bond, giving off energy. Here we're breaking that bond and getting two individual Cl's. I went real fast, so I'll go through that again tomorrow. Hopefully you stayed with me. I do feel like I went pretty quick. All right, so who needs this worksheet? Come on up.